think if you think you're going to get a free iPhone, you're probably out of luck. But thanks everyone for joining the talk today. So I'm Andy, a hobby chair on social media, so Twitter or Mastodon, can find me. I'm the security lead at Rokt, and we're happy to be sponsoring today because we are hiring. So come and have a chat to us at the booth during the break, and you can win some Lego as well. I started at Rokt several years ago as a software engineer, and it's kind of my background. I do full stack web development, front end, back end, and play with JavaScript, which, as you'll see soon enough, will be relevant for today's talk. I have two little monkeys who take up most of my time, but if I'm lucky enough, I get to do things like a bit of bug bounties or other explorations, and that took me to cert.sh back in December last year. So if you're not familiar with cert.sh, it's a website to search certificate transparency logs. So you can see every TLS certificate that was created by an organization in the last few years since certificate transparency became a thing. So I looked for a company, let's say example.com, and I got back a list of all the certificates that were created. And one in particular stood out to me, which was johndoe.dev.example.com or org. And it's kind of weird for two reasons. One, John Doe, you don't really see someone's name in a TLS certificate on a subdomain. But then two, it had dev in the name. And dev is usually really interesting from a security perspective, right? Because you can kind of get stack traces or other details that may not make it past into production, past the security team. So it's like, I want to go and have a look at what's happening and see what they're doing. And I was presented with this, which is a little bit unusual for a Western company. I have no idea what it says, but thankfully Google said this is related to the Saudi market, where example.com does not do any business. And then it also talks about best practical laptop, Dell Alienware, so on, lots of computer parts and things, which again is not the vertical that example.com is in. So I'm very sus, and I almost missed it, but I kind of saw this link number 2, and if you click it, it takes you to a very similar page that again has random content on a different topic in a different language, and a link to page 3, which has random content and so on. And it's got about 10,000 of those. So being a developer, I go and have a look at what's under the hood, and I spot this particular script being loaded from a Russian domain. So I go like, Western company, Arabic content, Russian JavaScript domain, something's fishy. Go and have a look at where this is hosted. So we do a DNS lookup. It tells me this is a CNAME to GitHub. Gives me an IP. Reverse DNS lookup tells me, yep, looks like GitHub for real. Looking at the IP address, that yep, this IP address belongs to GitHub and their AS number. And then when I do a curl, it gives me a little bit more information when I curl for that CNAME that's there, and it tells me this belongs to GitHub Pages, which is good news because now we know GitHub Pages as a product. We can go look up the documentation, see how you set up a website, see how you set up a custom domain name, and so on. But it's even better news because everything that's on GitHub Pages is also on GitHub. So we can go and do a search for some of that Arabic content, which brings me to Steppard, this user, who's slightly suspicious in that he has a lot of repositories with very similar looking descriptions, machine looking generated names. And he's got about 157 of those that all have, as I said, 10,000 pages of HTML content in random languages, So, I want to figure out what's going on, start poking at it. And I figured out that each of these repositories actually includes the domain name of a particular website. They're all different subdomains, and they're all pointing to GitHub. So I ran some bash and discovered that they're out of the 157, I think about 87 were still active subdomain takeovers leading to pages like this. So we report that to GitHub. They kind of agree this is not really what GitHub is for. So they go and shut that down. So happy days. They also now have domain validation, so those subdomains are now safe and they can't be taken over again. But I'm still wondering, why? What's the point, right? What's this Steppard guy up to? What is he trying to achieve with this? And that takes me back to the JavaScript that we discovered. And it's just a single line, as you can see, which is kind of normal. Most scripts are minified these days and will just show up like this. But luckily, we get the curly braces at the bottom there. So we get a bit more white space injected into that and make it a bit more readable. But this isn't exactly readable, if you agree with me. So, but we can get a bit of a feel for what's actually going on. So we see a bunch of scripts, or strings rather, at the top of the script here that are obfuscated. We can see there's one function here that's referring to that array of strings, and it's pulling out one element by index. We can also see what looks like base 64 character set being used there, and we can see a bunch of character manipulation. So, this seems to be base 64 encoded strings. Probably if they're using base 64, it's some sort of encryption. So they end up with characters that are unsafe in a JavaScript context. But I can't really work out what the rest of the script does. There's about 16 kilobytes of this. So I need to find a way to actually deobfuscate this and learn what's going on. So plan number one is the lazy way. I'm just going to debug it. We're just going to inject a whole bunch of debug, set a whole bunch of breakpoints in the Chrome debug tools, maybe add a few debugger comments, maybe add some console.log statements inside the code so it prints out what's happening as the code goes through. Looks something like this, as many breakpoints as Chrome will let me set. I step through that for a while, start getting a bit of a feel for what's going on, but what I'm seeing does not warrant 16 kilobytes of JavaScript. So I'm not really confident that I'm really seeing what's going on. I feel like it's just sent me down a path somewhere where it knows I'm debugging, and therefore it's just kind of getting rid of me. And it's not really showing me what the real code does. So I want a better plan. So plan two, we kind of saw it before. We used Chrome DevTools to pretty print to make that script more readable. So we're going to follow that same approach, but we're going to try to use a few other tools like Uglify.js or JSNice that will actually try to rename variables for you. And they use statistical inference to try to do that. But the goal is, again, to simplify the code, to make it more readable so we can make sense of what's actually going on and get confidence that, we're really seeing the attacker's behavior there. So we set up a local dev environment. We do exactly that, pop it in Chrome, and we get this, which is not really what I expected. So Chrome just shuts down the tab, no idea why. I assume I made a mistake. I try this 10 times over, try different tools, same outcome every time. But if I run the original obfuscated single line JavaScript, it loads just fine. So I can run it locally, I just can't mess with it. It took me a while, but I managed to kind of pause Chrome as it's doing this, and it dropped me in this function, which, as a for loop typically does, starts by just setting some kind of counter to say how many counts have you, gone through this for loop. So typically we see it being set to some random number there. I'm going to assume that's 0. So while that's less than a target value, we're going to keep looping, increase the counter by 1, and just go through that for loop a couple of times. We can see it's going to do that until we hit the length of something there, which is this variable 30c. Length means it's an array or a string, and then it's going to break out of this loop, and that's it. But what's unusual is that length is actually being reset at the end of this loop as well. And even more unusual is that we can see that it's pushing an extra element into something. So means that this is an array. So on every iteration of this loop, we're going to make the array one size bigger, which means we can never actually hit that stop condition because our count is increasing by 1 and the array size is also increasing by 1. So effectively what's happening is the array keeps growing, Chrome's out of memory, Chrome kills the browser tab. Easy answer is I try to get rid of this function, just does the same thing, puts me somewhere else in the code, similar loop, similar behavior. I spend an hour or two trying to work around this, and I'm hacking away at this code. And I kind of lose confidence again that I know what's happening, right? Like I'm changing the code. I don't know if what I'm doing is impacting the actual behavior of the script or not. So I want a new plan 3, which is we're going to do it the hard way, the slow way. And we're just going to have to, spend hours and hours trying to debug this. So I'm going to start with the original raw script, and I'm going to make small surgical changes. And after every change, test that it doesn't crash my browser and that it still behaves the same way it did before. And I'm going to use regular expressions to do that. I won't share the regular expressions today because you'll just be staring at the screen for a long time. I'll post some links at the end if you want to go deeper into that specifically. But I'll walk you through the general process. And a very simple example is the raw string just got split up into 2 here, constructor so we just go and write a regular expression to that, get rid of that, make that just back into 1 string. Along a similar vein, the script was using a hex for all the numbers. My brain just doesn't deal with hex all that well, especially when you're doing maths operations with it. So I just converted this all back to decimal. But ultimately, we know what this is. There's no variables in here. There's nothing dynamic here. We can pre-calculate what this is. So again, write a regular expression, just run eval over that. And now we come back with a number 327. A similar change that I did was JavaScript supports two types of way to calling functions on objects. You can have this bracket notation or this dot notation. And part of it is just, again, easier on the eye. But if you change to dot notation, your IDE will actually recognize that as a function call as opposed to just a string being used to index an array. But also it just kind of reduces, some of the noise of the brackets and the quotes and so on. We also go and rename a few things, very simple, but we know kind of, this is an array of strings. We know there seems to be some decoding or decryption function. So it just kind of helps us understand the code a little bit better as we loop through it. And as we do that, we start seeing behaviors like this, where we have two different functions, but both of them are doing exactly the same thing. Even more, there's 4 arguments here to these functions, but only 2 of them are actually used. So 2 of these arguments are just bloat, they're just dead. So we can just get rid of them. And finally, this is just calling decode and is just adjusting that first argument, with a very simple operation, subtracting or adding 866. So everywhere that we find a call to, one of these 2 functions, like 5D, whatever, with 4 arguments, we're just going to simplify that down, change that straight into a call to decode, drop 2 of those arguments, adjust one of the arguments by that value that we saw earlier. But as we do that, we also see the same behavior in the decode function now. We've got 2 arguments there. And we've also got the first argument being offset by a fixed value. And take my word for it, the second argument's not used, but we can apply exactly the same logic to this. Everywhere that we find a call to decode with 2 arguments, we drop one of them, adjust the other one. But now decode 71 is pretty straightforward, right? We know that's looking at that array of strings. It's getting out the 71 element and then doing that deobfuscation. So we can just go and run that in a JavaScript REPL and go and pre-calculate all that and get all the strings back out. So we just go and, substitute effectively all the calls to decode with whatever the resulting string ends up being in the end. So after doing that, that 16 kilobytes of JavaScript, comes down a lot in size. All that obfuscation slowly starts disappearing. We can start seeing what's going on. And if we loop back to plane 1, we tried doing console logs, but console log didn't work because the script was actually replacing the browser built-in console object with a mock that had the same log, warn, info, and so on functions, but replacing them all with empty functions that didn't do anything. So console.log, you could still call it. It would be successful. It just wouldn't print anything, so you can't see anything. So we just get rid of that entire block of code altogether, nice and easy. Similarly, we can now kind of figure out why plan 2 didn't work and where we had some trouble with the out of memory, the OSNAP Chrome page. What's happening in JavaScript that's pretty cool is that when you have a function, like this simple function here that returns this, you can call toString on it. And when you call toString on it, it'll actually give you the code that represents that function. But not only that, it's actually the original code that was written as it was defined in the JavaScript file. So the first example is what the obfuscated script was expecting. It's minified, there's no white space. So it just returns, function return this, with no spaces or no new lines or anything like that in it. Whereas if you try that in all the automated tools that I used, would include extra white space and new lines to make the code more readable. But as a result of that, the string representation changes. And what the string was doing was, or the script was doing, was simply checking what's the length of this string. If the length of this string is not that bare minimum 12 or 13 characters, then somebody's messing with this. And if somebody's messing with it, then just go on a completely different code path and stop doing the malicious stuff that we're trying to do. At the end of all that, a beautiful 2 days of time, it turns out that all this does is redirect you. So 16 kilobytes and 2 days of time just to say, did you come from a search engine? And it had about 20 search engines listed. If you did, set a cookie and then go and redirect the user to whatever that domain is there. It also, if you haven't come from a search engine, checks whether you have that cookie set. So if you try to press back in the browser or something like that, it'll redirect you anyway because that cookie is there. So as a real user, you're never supposed to see that Arabic content that I discovered by accident. So, the obvious question is, what is it redirecting us to? Which is this. And you've probably seen very similar pages from Cloudflare or something else to say, hey, are you a real user? Are you a bot? It sits here for about 5 seconds before it redirects you again. And I'll save you the pain, but similar JavaScript obfuscation that I went through. Luckily, most of the regular expressions from the earlier exercise worked on this one as well, but this only took about an hour. But we discovered that it's taking 91 fingerprints of your browser, your graphics card, your CPU, whatever they can get their hands on, your screen size, and so on. It takes all those, puts them all in a JSON object, stringifies them, encrypts the whole lot, sends it to a server, and then the server decides where to redirect you. And again, I don't have time today to talk you through 91 attributes that it's fingerprinting and how it's doing it, but I'll share some posts at the end that you can go and have a look at if you want to dig deeper into that. But to give you a flavor, 2 unusual ones, I guess, for what you would expect a normal or enterprise script to do. One is it's going to go and look for signs of browser automation. So any browser automation tool like Selenium or WebDriver, will kind of leave some certain fingerprints in the DOM that you can detect. So call phantom, underscore phantom, and so on. So then they can actually change their behavior. So if this is a bot, if this is an automated script, they're going to do a different behavior compared to if you're actually a real user. More suspiciously, they're also looking for web antivirus. So if you're running Kaspersky or Avira or Symantec or something else, they can detect that again because they leave some fingerprint inside the actual DOM, inside the web page of what they've scanned. At the end of all that, it redirects me and it takes me here. Maybe this is TikTok, and maybe they have some new customer acquisition strategy here that's a bit unusual, but I doubt it. So I tried this on Safari and Firefox, which gives me, kind of what I expected, which is, hey, congrats, you've won a free iPhone. It's that easy. All you have to do is pay $2 shipping, and we will happily deliver that iPhone to you. Even better, it's all COVID safe, no personal contact. We're just going to leave it at your door, so you can be really, confident that we have delivered your iPhone. I did this about a year ago. I tried to get some more slides. Unfortunately, they've changed tactics. If you're in Sydney right now, you get a $750 Amazon gift card instead. But when you click through on that, it actually takes you to a different website altogether again. And this is being run by a company, Rewards Giant, or a group. And once you start seeing you're not winning a gift card anymore or an iPhone anymore, now you have to complete a whole bunch of purchase requirements and terms and conditions and all kinds of other stuff, and fill in tons and tons of forms of personal details and questionnaires about how often you go shopping and where you go shopping and so on. So that free iPhone's probably not going to come anytime soon. To kind of recap, the whole point of this actor was poisoning search engine results. So they have 10,000 garbage pages in different languages with different content to try to pollute what actually shows up in Google and Yahoo and all these search engines. So an unsuspecting user would kind of get these results in their top 10, would click on it. That JavaScript that we saw at the beginning would detect that you've come from one of these search engines, redirect you to that loading page, which fingerprints your browser, redirects you again, or posts that to a server, which redirects you again, then depending on who you are or what you are. So if they suspect that you're kind of messing with the traffic, or if they're traffic that they're not interested in, they'll send you to TikTok or something similar. Most of the time that I've seen it, it sends me to that survey page, congrats, you've won an iPhone, and so on. But I ran this on a cron job for several months just to kind of see what else it would send me to. And 99% of the time, it sends me to a Dutch hosted IP address for congrats. But every now and then, it sends me to a Russian IP address and does something completely different. I haven't gotten there yet, but if VirusTotal is to be believed, they're actually dumping Agent Tesla malware from that IP. So my research kind of continues. I'm trying to figure out, what else they're doing. I'm trying to figure out how much bigger this is. The domain that this is hosted on is changing every 30 minutes. So to get a new domain name every 30 minutes, if you assume $10 per domain name, is a fair bit of money over the course of the year. So I think this network is much, much bigger than what I've uncovered so far. So I'll keep digging into this and hopefully, have something more to report next year. But until then, I want to encourage all of you to be curious and to find your own kind of rabbit hole like this, because you can read plenty of Hacker News articles and whatever, but really it's digging deep and really getting into something that's going to kind of help you a lot more, I guess, in terms of learning and guiding your understanding, and that type of learning accumulate kind of adds up over the course of your career, year after year. So find a rabbit hole, go down it, keep falling, learn techniques, learn technologies along the way. Share early as well. I had the fortune of sharing this with one of my colleagues who just happened to sit on a database of new domain name registrations from the last 6 months. And we found at least 10,000 domain names that this actor has been cycling through in .com, .net, and other TLDs. So share. People that might have tools, might have input, might have ideas on how you can proceed. Take notes, especially if you want to do B-sides talk, it helps. On the technical side, I was working in Python at the time, so I kind of wrote all this regex stuff in Python, which was a really dumb idea, because when you try to run eval Python is not the same as eval JavaScript, so it just makes life a lot harder. So if you're doing any sort of exploits or deobfuscation, stick with the same language, I think, because you'll just avoid those edge cases. On the maybe, I think I'd like to experiment with using abstract syntax trees for this rather than regular expressions. The concern with that is that the dynamic nature of JavaScript, you don't really know what you're evaluating until it actually runs. So yeah, verdict's not out on that one yet, but time will tell. Thank you very much. And as I said, here's some links, so there's more details online.